All right, ladies and gentlemen, we're starting some stuff with proofs, okay? To prove something, it's kind of like finding a general form of how to do it, okay? General form means usually we do something without any kind of numbers, okay? We're going to prove that the composite of reflecting two translations over two parallel lines produces a translation that is double the distance between the lines and in direction of the mapping of the first line to the second line. Okay? So, notice we don't have, we didn't label the lines x equals anything or y equals anything like that. Okay? We're simply, if the point is between the two parallel lines. We've got this triangle and we're specifically looking at point A. Okay? Because you could look at each individual point of the triangle, but we just want to prove that it's twice the distance away, so we're just looking at one. Okay? All right. First, we're going to reflect over line 1. Then we're going to take that and reflect it over line 2. Okay. I think one of the best ways to do this is to get a mirror. You could also use patty paper to do this. You can just do it without anything if you would like, okay, because it does make logical sense. When we prove it over intersecting lines, you might really want to have one of those two things. Some people work better with mirror. A lot of people work better with patty paper. It's easier to see sometimes. Okay, so we're going to construct a line that is perpendicular to 1 and 2. This is the first step. Okay, this is very important. We're going to construct a line that is perpendicular to line 1 and 2 and goes through point A. Okay, since the lines are parallel to one another, since the lines are parallel line to a perpendicular line, they will be perpendicular to the other parallel line. Label the intersection with line 1, okay, 2B, and then label the point with line 2, C. Label the distance from A to B as X, okay? A to B is X. Now we're going to take this whole thing and reflect it over line 1 without turning the page. Those of you who've done it, don't say anything. But without turning the page, what do you think the distance, if we reflect A over line B, what do you think is going to be the distance from B to the new A? Yes?
X.
It is going to be X because we reflected it, right? So it should be the same on each side. Andrea, would you grab me a piece of patty paper and a mirror? Okay, so when we reflected it, we got X on each side. So I want to make sure you guys understand how to use your instruments to do this. I like to, we can simply trace line 1 so we know which one we're reflecting over. We can trace that triangle, label the top A, and we've got the distance right here is X. When we reflect it over the line, we simply flip it over and line 1 up with it. Do you see how that works? I really like patty paper for that. I feel like it's a really nice visual of how far it went over. It's really clear. Okay? Then you can just move your paper, mark A where it goes, know that X is right there. Another way, again, whichever line you're reflecting over, you can put the mirror right there and you can see straight through. Okay. All right. This is where placement is really important. We're going to reflect A naught, okay, over line 2. So let's look at this. We're going to trace line 2. Make sure to label line 2. We've got all of this distance, right? All the way to A naught. This is X. This is X. But what's the distance between A and C? I'm going to label it Y. We don't know that they're exactly the same. We don't know that it's exactly the middle. Okay? So I'm going to label it Y. So I'm taking this whole thing and I'm reflecting it over line 2. So we should see this whole distance here, okay? So I've labeled this part Y, but A naught, this whole triangle, okay? If we were to Mark the triangle. You know, we've reflected the triangle over here. Okay? And then we've taken that whole thing, reflected it all the way over here. That's my triangle all the way over there. So now I'm going to list the distance between A and A not, this whole distance. How many X's do I have? 2. How many Y's do I have? Let's count them again. Here's 1. There's 2. Do you see that? That's a very common mistake to only read this one Y. Make sure you see both of them. So the distance between A and line 1, the distance between line 1 and line 2, do you guys see that? What's the distance between line 1 and line 2? X plus Y, right? And we see that between A to A not is 2X, because we're looking from here to here. 2X plus 2Y, which is the whole point, right? You want to see that this doubles, right? That's the whole point of this, is that the distance between the two lines is doubled to find the distance between A and A not. Okay. Let's go over the rest just so you're sure what you have to do. There are 2 drawn on here, okay? But there are 2 more you have to do. First, this one, you're first reflecting over line 2, and then you're reflecting over line 1, then line 2. Case 3, you're reflecting over line 1, and then line 2. Okay? Case 4 and 5. If you're reflecting first over, if we've done the triangle where it's in the middle, we've done it where it's in the right, and we've done it where it's on the left. Okay? So the next ones you were going to reflect line 2, then line 1. Okay? Oh, never mind. That is not true. You're going to reflect where they're on a line. This one, 4 and 5, you're doing on a separate sheet of paper. If you feel like you have room, you can cut this in half and draw it on here. This one, you're reflecting where the triangle or point A is on line 1. And the next one, you're doing it where A is on line 2. Okay, so it'd be like if it was right here. What happens when you reflect over line 1, then line 2? Okay. All right, so you literally have 4 more to go. Your homework for tonight is classifying triangles. So let's just go over these. We know acute is greater than 0, but smaller than 90. Right is exactly 90. Obtuse is greater than 90, but less than 180. 180 is a straight line. Perpendicular lines form right angles. Okay. Complementary add up to 90. Perpendicular pair are 2 triangles that add up to 90 that are divided by an angle. They're right next to each other. Supplementary add up to 180, and a linear pair stays in a straight line. Okay? You're going to, in the figure, M is measure 7 is 90, and you're going to name the angle which appears for all of these. Okay? You're going to figure out if they're complementary, what the other angle would be. If they're supplementary, complementary, and supplementary. Okay? You have lots of time to work on both of these. If you finish, I feel comfortable giving you guys the next activity. Okay? Is there any questions before I let you guys work on this? It doesn't matter which one you do first. Classifying triangles is due tomorrow, if that helps.